Okay, so this aspect of your Show What You Know week includes 3 problems. One of the problems I'm going to ask you to look at in this particular egg puzzle is solving a system of inequalities. And we have 2 inequalities here, and both are in standard form. So we have a little bit of work to do. And so we're going to start with this first inequality up top. We have 3x plus 2y is greater than or equal to -2. And before we can make any decisions about it, we are going to rearrange it into slope-intercept form because we're not sure right now which side we're going to shade. We're not sure what the slope is of the equation, but we're going to use the process of changing it into slope-intercept form in order to be able to graph it. So let's start here. 3x plus 2y is greater than or equal to -2. I always start far away from the variable, so I'm going to subtract 3x from both sides. Okay, and I end up with 2y equals -3x minus 2. Okay, so now I still do not, whoops, that should be greater than or equal to, my mistake. So now I'm going to divide by 2 in order to get that y by itself. And I have to divide all of the terms by 2 in order to make sure I'm following all of the order of operations rules. And I get y is greater than or equal to -3/2. I can just leave that because 3/2 is a nice rise over run format. Minus 2 divided by 2 is going to give me -1. That's my first equation or inequality. So there's some things that we know here. We know it's going to be a solid line. We know that it is going to be above because the greater than symbol means I'm going to be shading above the line. We know the slope is -3/2. And we know the y-intercept is -1. The slope-intercept form is always super valuable for us. So let's start. We know first we always start with that y-intercept of -1. Let's plot that on here. And our slope is -3/2. So I'm going to go down 3, 1, 2, 3, right 2. There we go. And I'd like to get some more points over on this side. So I'm going to go up 3, 1, 2, 3, left 2. And it looks like I can go again, up 3 and left 2. Okay, and we know here that it's going to be a solid line. So let's see if I can get a solid line in here that looks relatively decent. Okay, that looks off. Why does that look off to me? I think my graph is a little crooked. So here we go. There we go. All right, so solid line, and we are going to shade above the line. So let's grab some shading and shade above that little fella, okay? And above, if I start at my y-intercept and move up there, even though it's kind of a steep line, I can tell that I would shade over here on this right side. So all of this business over here is considered a solution to that first inequality. Okay, every point, if I plugged it in, it would make it a solution, including the points that are actually on the line. Okay, all right, so let's choose a different color here and work on our second inequality. This also is in standard form, so I'm going to have to do a little rearranging, which we know this, we've been doing a lot of this, so I don't think it should be too intimidating. My target is y for slope-intercept form to get by itself, so I'm going to start up way over here getting rid of x by subtracting x. That's a positive x, so in order to get rid of it, I have to subtract x from both sides. So those are going to cancel, and I end up with 2y is less than or equal to -x plus 2. Now, I haven't done any sign changing. Thank goodness we don't have to deal with any flipping of the signs. We haven't multiplied or divided both sides by a negative number. And this 2 is positive if I divide by 2 on both sides. So every term has to get divided by 2. And that cancels, and we're left with y is less than or equal to, there's a little invisible 1 right here, -1/2 x plus 2 divided by 2 is 1. So that's our inequality for the second graph here. And we know, of course, 4 pieces of information. We know we're going to be shading below the line because it's a less than. All right, let's document that. We know it's going to be a solid line because of the equal sign. Okay, we know my slope is right here, -1/2. And we know my y-intercept is +1. Those 4 pieces of information we know. So let's start graphing that over here, all right? Y-intercept is +1, so we can plot that here. We go down 1, right 2, down 1, right 2, down 1, right 2. Oh dear, and I'm going to go backwards, up 1, left 2, up 1, left 2 in order to get that, okay? It is a solid line, so let's see if we can get that solid line there, okay? And our shading is going to be below the line. So let's see if I can find a pretty color here. And my highlighter, we'll have to use yellow because I think pink is just too obvious. All right, so we're shading below this red, oh, sorry about that, went over a bit. Below the red line over here. I've had too much coffee, guys. Sorry. Okay, over here. There we go. Okay, so the solution, even though we've got all this shaded yellow, the solution to our system of inequalities is going to be this overlap business in here. And that, of course, goes on forever. So it's the overlap here, including the solid line. So anything falling on that solid line would also be a solution. Okay, so there we go. That's our first problem. Okay, the second problem that we're looking at right now is to simplify fully. And we do have a negative exponent on the outside of a parentheses. So we've talked in class before how a negative exponent causes you to shove and to move some stuff around, but we want to deal first with the fact that this -2 exponent is outside the parentheses. So that -2 has to apply to everything inside the parentheses. So let's rewrite that first just to see what it looks like so we can get rid of the parentheses. So we have 2 to the -2, a to the -2 over 9 to the -2 and c to the -2. Okay, now we got negatives flying around all over the place, but we know that that's not something to be intimidated by. Let's see what we do. We'll address each piece, each factor on its own. 2 to the -2, well, it's got a negative exponent, so we have to flip it. So 2 comes down here to become 2 squared. The a to the -2, that also has to get moved down, so it becomes a squared, okay? This guy down here, 9 to the -2, he has to get moved up, so he becomes 9 squared up here. C to the -2, he also gets moved up, so he becomes c squared. Now we do have a little bit of simplifying to do because we can't leave this 9 squared and the 2 squared. We have to see if there's a way to simplify those. 9 squared is 81. C squared over there, and 2 squared is 4, 4a squared. All right, now 81 and 4, I don't know, does 4 go into 81? 4 times, I don't believe it does. So we'll just leave that as our final answer. Okay, there we go, a little bit of practice with simplifying some exponents. Next, we are going to solve an equation, okay? Now this equation, we have 3x plus 2 minus x equals 2 times the quantity x plus 1. And we're going to start, I think I see some parentheses, but I also see where I can combine some like terms, just so you're following order of operations. It really doesn't matter where you start. So I think we're going to get rid of parentheses first, because that's been our main push this year, is to work on getting those parentheses gone. All right, equals 2 times x is 2x, and 2 times 1 is 2, okay? All right, so let's see, let's combine like terms. Let's combine 3x and -x. So we get 2x plus 2 equals, 2x plus 2. Your spidey senses should be tingling right now. All right, let's move the x's over just to see what happens. All right, I'm going to subtract 2x from both sides. Dun, 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 dun. There we go. And that cancels, and that cancels. So I end up with 2 equals 2. Okay, so we've talked about this. When the variables vanish, okay, my variables have disappeared. Now you take a look at what kind of statement you have. I have a true statement. And that true statement must lead you to make a decision. The answer is not 2. Please don't say the answer is 2, okay? We get variables vanishing and we end up with a true statement, so that means you have to draw a conclusion. The conclusion here, because I have a true statement, is that there will be, the solution here is all real numbers, okay? All real numbers. So in other words, I can choose any possible number to put in here for x, and whatever I put in here for x, it will make a true statement. I could choose -1000, I could choose 812.4, and it will make it into a true statement. Okay, so the answer is that every possible number is an answer. Okay, and that is very important for you to be able to communicate, because this is definitely a special case. Now, what if I had a different problem and I did all my work and I ended up with a false statement? What if I ended up with 4 equals -2? Okay, that is a completely different scenario. If I do all my math and end up with variables vanishing and I have a false statement, now that means something completely different, and you have to make sure that you can draw that conclusion that if variables have vanished and I have a false statement, then there is no solution. There is no possible number that can make the particular whatever equation we started with that would make that equation true. Okay, so it's just a little review on solving equations, some no solution, all real numbers solution, and all that good stuff. Okay, all right. Hey, thank you so much for tuning in, and you guys have a wonderful day. Bye-bye.